trapezium. So one pair of sides parallel, the other pair of sides non-parallel. So this is a trapezium. AB parallel CD. These will be the diagonals AD and okay, let's just name it correctly. These will be the diagonals AC and BD. And yeah. So now in trapeziums, right? The first thing you need to realize here is sort of combining what we learned in triangles to trapeziums, which is the principle of parallel lines creating similar triangles. So if I sort of join these diagonals here, these two triangles will be similar. Basically, AOB similar to triangle COD. Why? Because these angles are alternate angles will be equal. This is vertically opposite. Even these are alternate. You can reduce all three. So this triangle will be similar to this triangle. So these are similar triangles. So basically the ratio of sides would be same. So for example, if you know that this is for example A and this is K into A, so the proportion of this side to this side is K times. So this will also be in the proportion of K. So if this is X, then this will be Kx. If this is Y, this will be Ky. Proportion of sides, just basic. So if OB is Y, then OD will be Ky. If OA is X, OC will be Kx. Similarly, the area of this, if this area is denoted by, let's say, anything, let's say M, so this area would be K square times M. So this is the triangle AOB area, this would be triangle COD area. So this area is M, so this area would be K square times M, where K is the side ratio. Okay, so we know these two areas. But the thing is, how to find these two areas, right? Now, there is a direct formula for the total area of a trapezium, which is basically half into sum of parallel sides into height. And we had used that actually in the octagon question as well. This is a standard formula for area of a trapezium, but for this you need to know like the side lengths and you need to find or calculate the height if it's not given, etc., etc. But if like you're given area of component triangles, how to find that? So we know that okay, this and this will be in a similar proportion of K square. Cool. So what will be the area of this and this? Now you need to know one thing, that in any quadrilateral of the world, basically you draw any quadrilateral and you draw the diagonals, the product of the opposite segments areas are always equal. So for example, if this is A1, this is A2, this is A3, this is A4. So this area into this area will be equal to this area into this area, always. A1 into A3 will be equal to A2 into A4. Right. Now, if for a case of a trapezium, these two areas are always equal. So this area and this area is always equal. Right. So to say basically that A2 and A4 here is equal. So basically this would be A2 square. So basically A2 would be equal to root over into A1 into A3. To say that, if we translate this into a trapezium concept, so basically each of these areas would be a root over of the product of this area and this area. So for example, if this area was M, this area was K square M, then BOC will be the root of M into K square M and equal to area of AOD. These two areas of a trapezium will always be equal and each will be the root over of this into this. So in this case, like it would be Km. So essentially, if we have this trapezium uh, with areas of A and B, so this will be root AB, this will be root AB, and this A and B will also be in proportion of the square of the sides here. So the total area will be A plus B plus 2 root AB. Now, or you can say that this area would be the geometric mean of these two. Geometric mean is also root AB. Right. So this is pretty important. Questions have been asked directly on this, and we'll cover a question or two from this concept, but essentially like, so this is the first important concept for trapezium, or probably second if you count the area funda as one as well. The second concept of the trapezium is, and actually not the second, like we'll cover like two, three concepts at once because they all use the same this thing. If you, this is again parallel to this, if you have these two diagonals, right, let's denote this side by x and y, the parallel sides. The midpoint of the diagonals, if let's say these are the midpoints of the diagonal, this is PQ, so PQ are midpoint of diagonals. So then the line segment PQ will be equal to y minus x by 2. Basically the difference of the parallel sides upon 2. Depending on which is bigger, the first one will change. But yeah, the difference of parallel sides by 2 basically. So the midpoint of the diagonal. So this is one result. And these are all just direct results. The second is that if you join the midpoint of the non-parallel sides, for example, this, and if this is the midpoint, so let's say PQ here, our midpoint of non-parallel sides, PQ will be, and this is again x and y, parallel sides, so will be equal to x plus y by 2, which is sum of parallel sides by 2. Cool. So simple difference of parallel side by 2, sum of parallel side by 2, by for difference of like for length of the line joining diagonal midpoint and length of line joining the non-parallel side midpoint. There is a concept of, if we draw, like if we sort of divide the triangle into two equal areas, if we draw a line sort of that divides the trapezium into two equal areas, so A1 equal to A2, if this line is the one that does that job, then PQ will be equal to root mean square of the parallel sides, and I'll just explain that. It is a good way to remember root mean square of parallel sides. Now what does root mean square means? Root of mean of square. So root of mean of square is, what is the mean of the square? X square plus y square by 2, x squared and the mean of squares and the root of this. So PQ will be equal to this. The line segment, like dividing the trapezium into two equal areas, important. Okay, and if you see, right, so all of these formulas are using only the parallel sides then. So yeah. Now we'll take a formula which uses the non-parallel sides as well, which is something called a sum of squares of the diagonals. So if in this case C and D, the sum of squares of diagonals, so AC, and this is X, Y, this is A, or no, not AB to be confused, but this is, let's say, M and N. So AC square plus BD square, the sum of squares of diagonals will be equal to the sum of squares of the non-parallel sides, n square plus n square, plus 2 into product of the parallel sides. This is the result basically. So sum of squares of non-parallel sides, n square plus n square, plus 2 into product of the parallel sides. Sum of squares of diagonals. Okay, so typically, like if one of these applications comes directly, right, to say that okay, and we can use them directly, but in case like where we have to do some working, we'll just take a few questions of that sort. And like while we're on this topic, right, for a parallelogram, basically, just because we discussed this topic right now, the sum of squares of diagonals is the same as sum of squares of sides. So we'll cover this when we talk about quadrilaterals as well. But yeah, like AC square plus BD square will be equal to AB square plus BC square plus CD square plus AD square. Sum of square of sides is sum of squares of diagonals in case of a parallelogram. For a trapezium, sum of squares of diagonals will be equal to sum of squares of non-parallel sides plus 2 into product of parallel sides. Let's see a few questions on trapezium, right? A trapezium ABCD is diagonal intersecting at O. If OD is to OC is 1:4 in area, AOD is 12, find the area of the trapezium. Seems familiar? we have just seen that the trapezium creates that scenario of similar triangles and the similarity proportions. And the area also, we just saw that how those areas are distributed. So a trapezium ABCD has diagonals intersecting at O. OD is to OC is 1 is to 4. So this is 1 is to 4. So immediately I should realize that the area of this, if it, let's say if it's X, then this will be 16 of X in terms of area, because the area ratio is 16. And area AOD is given as 12. AOD is given as 12. Right?
Sir,
Yeah.
ratio of OD and OC is given. You
Yeah.
have taken OD and OB.
Oh, okay. It's actually the question typo in the question itself. That's my question, so it may be a typo there. This should be OD. Yeah. Actually, it should be OD is to OB. Yeah.
Okay.
So 1 is to 4, and again, thanks for pointing that out. 1 is to 4, and the ratio of areas would be 1 is to 16. So now the total, like this is 12, and we know that for a trapezium, this area is equal to this area, so this will also be 12. So the total area would basically be 24 plus 17x. We don't know what x is, we need to figure out. We know that this area 12 is equal to root over of this area into this area, so this is basically root over 16x square we just saw. So basically 140 pro, like each of these areas is root AB, that's why. 144 equal to 16x square, x equal to 3. So the total area would be 24 plus 17 into 3, which is 24, 51 and 85. 75 actually. Done. So again, a simple question, just making use of the concept that how the areas get distributed in a trapezium. Isosceles trapezium circumscribe the circle. One of the parallel sides of the trapezium is 3 times the other, and the perimeter is 40. Find the area of the trapezium. Now, before we even start this question, right, again, it's a similar question to, like, in topics like trapezium, etc., right, they cannot, even in polygons, right, they cannot create more varieties. It will be like manifestation of the 3 or 4 concepts that we have learned. So it will be limited to these only. So like whenever you sort of encounter questions on these areas, right, so just recall all those concepts and just see which of those could be applied. It will not go outside of those 3 or 4 fundas. So isosceles trapezium circumscribe the circle. One of the parallel sides of trapezium 3 times the other. Okay. Now before we even get to decide, one concept we should know in general, like for any quadrilateral, right? And it's a derivable concept immediately, but just for this thing, even if it was a general quadrilateral, not even a trapezium, if you draw a circle, right, if like we say that if a quadrilateral ABCD circumscribe the circle, which means the quadrilateral is outside the circle, so you can always know that AB plus CD equal to BC plus AD. The sum of opposite sides will always be equal if there is a circle inside. How? Let's say this is X, then equal tangent rule says this will be X. If this is Y, this will be Y. If this is Z, this will be Z. If this is W, this will be W. So you have this equivalence basically, right? So AB plus CD will always be equal to, so X5, X plus Y plus Z plus W. Even for these two, you have X plus Y plus Z plus W. So whenever there is a circle inside, just remember that this can be applied. So like some of the opposite sides will be equal. The same follows for a trapezium as well. So that is why I have put this question to basically illustrate this. Yeah. So one of the parallel side is 3 times the other. So if this is X, this would be 3X. And since this is X and this is 3X, the trapezium isosceles trapezium means that the non-parallel sides are equal. Isosceles means that non-parallel sides are equal. So if this is X, this is 3X, the sum of these two is 4X. We know that the sum of these two will be the sum of these two. We just saw. So the sum of these two should also be 4X. So this will be 2X, this will be 2X. Right? The perimeter is given as 40. So basically the sum of these, which is 3, 5 and 8. 8x equal to 40, x equal to 5. So I know the sides of the trapezium basically. So if I were to write here, so this will be 10, this will be 15, this will again be 10, this will be 5. So isosceles trapezium, we know the sides, how to find the area. Again, we had seen that how to visualize the diagram into components which we are familiar with, right? So applying that same principle here, if these two lines are parallel, I can draw perpendicular from this and this. So then this figure becomes from a trapezium into a rectangle plus two right angle triangles. I know how to find the area of rectangle, I know how to find the area of right angle triangles. All I need is the sides. Now for this rectangle, I know this 5. I don't know the height, but we can find the height. We'll see how. I know that this entire thing is 15. This is 5 because this is like, this is a rectangle, and so this portion is 5. So because this is isosceles, so these two triangles will be congruent, or basically like these two triangles will be identical in a way because it's an isosceles trapezium. So if this is 5 and this total is 15, so this will also be 5, this will also be 5. Again, this won't have taken place if this was, let's say, 12 and this is 10, or like unequal. Because this is equal, so these two triangles are congruent and all their parts like will be sort of equal. So now this is 5, so this total is 15, so this is 5, this is 5. In this triangle, this is 5, this is 10, you can find this out. This will be root over 10 square minus 5 square, so which is root 75, which is 5 root 3. And again, because these are parallel lines, so height will be the same, whether you draw here, whether you draw here, whether you draw here. So this will also be 5 root 3 basically. So the height of the trapezium is 5 root 3. And the parallel sides are 15 and 5 as we know. So sum of parallel sides is 15 plus 5, which is 20. Area will be half into sum of parallel sides into height, 50 root 3. Again, this was an isosceles trapezium, so it was simpler to figure out these remaining parts. We just divided the whatever was remaining, which was 10, into 2 equal halves. But we'll see a case where this is not, like, it is not as simplified. But yeah, the main catch in this question was that the opposite side will have equal length because of the tangency thing that we saw. And yeah, and as we saw, like how the areas, like basically the area formula, that's basically half into sum of parallel sides into height, which we have seen is getting used. This came last year in CAT. The sides AB and CD of a trapezium are parallel. AB being the smaller side, so if this is AB, this is CD. C is the midpoint of CD, so okay, this is the midpoint. And ABPD is a parallelogram, so basically this is a parallelogram, which is okay. And sorry, this line should have been straighter, yeah, probably, but yeah. This is a parallelogram. Now it says the difference in area between the areas of parallelogram APBD and the triangle BPC is 10. Find the area of the trapezium. Okay. So basically this is, we know that these are parallel lines, so the height we can take from anywhere, it would be the same. So basically this would, if we draw this line, this would be the height for both the triangle and the trapezium. The trapezium would also have the same height, or the parallelogram would also have the same height. Basically this is the height for the triangle, the parallelogram, and the trapezium, because of the parallel line thing. So area of parallelogram we know is base into height. It's a formula. Area of a parallelogram is always base into height. Right. So if you see this parallelogram APBD, the base here is DP. Let's say we don't know the length. Let's say this is X, and since P is the midpoint, it is given. So this will also be X. This entire thing will also be X. So your parallelogram APBD will be the base, which is X, into height. We don't know what this is. Let's take this as an H for now. So XH. Area of the triangle BPC, which is the other part given in the question. BPC will be half into, again, X into H. We are given that XH and half XH differ by 10 centimeters square. So basically to say that half XH will be equal to 10, so XH will be equal to 20. We need to find the area of the trapezium again. So if XH is 20. So area of trapezium is what? Half into sum of parallel sides into h. H will remain as h. What is the sum of parallel sides? 2x and x. Why is this x? Because this was a parallelogram. So opposite sides of a parallelogram are equal. So if this is x, this is also x. Parallelogram opposite sides are equal. So sum of parallel sides will be 2x plus x will be equal to 3x. So this is 3 by 2 into xh. So just 3 by 2 into 20, which is 30. This is the answer. Pretty short question, right? Like no high funda involved, no like fancy concepts involved, just a similar, like basically like area of triangle, area of parallelogram, and then just figuring out uh, using the area of the trapezium. This probably is the last question for the day. Would yeah. So and this would wind up our topics of polygons and completely. ABCD is a trapezium with AB parallel CD, AB 21. So sides are given basically. So ABCD. Okay, AB is a larger one, so let's just keep it at that. 21 BC is 7, CD is 6, AD is 8. Find the longer diagonal of the trapezium. So one is this, one is this. Visually only you can see that this is a longer one. Right, again, we have no like direct formula to find a diagonal of a trapezium. Right. There is no like 90 degree for us to use like Pythagoras and stuff and all of this. So again, our old concept of breaking a figure down into familiar components comes to rescue here. So basically, like if we draw a perpendicular here and we need to find out this triangle, if we can find out this length and if we can find out this height, we can get this diagonal. Okay. So this is h, and if we draw another perpendicular here, the reason we draw this perpendicular is to sort of say that okay, if this is 6, this part of the 21 will also be 6. Let's take this as x and this as y. So in the previous case, since it was isosceles, we were taking the other outstanding parts to be equal. Here it is not isosceles. So we need to work for it. So basically, to say that 6 plus x plus y will be 21, x plus y will be 15. This is h, this will be h. So this is one equation. We need one more equation. Basically, so this is h now, and this. So in this right triangle, we can say that it's h square 64 minus x square. Similarly, in this right triangle, we can say h square is, and this is a standard approach for calculating diagonals or even areas of trapeziums when sides are given, and it's not simplistic as isosceles, etc. So then like this method is sort of a standard there. So this is 49 minus y square. So both of these are h square, so we can say 64 minus x square is equal to 49 minus y square. So basically x square minus y square equal to 15. Okay, and we know that x plus y is also equal to 15. Right, so this we can say, you can actually directly, like for this particular case, you can directly see that x and y 15 and the difference of square is 15. So in our like the common squares, we know that 64 and 49 differ by 15. So 8 and 7 could fit. But still, like from a method standpoint, this will be x minus y into x plus y equal to 15. X plus y we know is 15. So x minus y equal to 1. And put x and y in this and get. So x will be equal to 8, y will be equal to 7. This is 8, this is 7. So in this triangle, like we need to find out AC, right? So in this triangle, this side is what? This side is 6 plus 8. So one side is 14. One side is h. H now we can find out. H was 64 minus x square. So 64. Okay, in this case, okay, the data may be off, so it is giving us a 0. But essentially, this is the method. So h square would be 64 minus x square. This is a like a made up number, so that's why it's coming out of 0. But otherwise, yeah, h square is 64 minus x square. So you can find the height using this triangle. You can find the diagonal of that.
Hello.
Hello, yeah.
So, by looking at the figures, sir, how do you get to know that AC is the longer diagonal?
Which diagonal seems longer here?
No, means I think both. I think that both are same. Means, are you calculating something distance or?
No. So, like the lower side is 21, right? And the upper
Yeah.
side is, so okay, you can see it this way. So let me just erase everything. You could do it taking BD as well. It does not really matter. Like here, the values are also bogus, but the point was to illustrate the concept here of how to calculate. So, for example, if this is uh, 6, and to find out this is uh, this is 21, this is 8, right? And this is 7. So now if you think about the construction of this figure, right? So this is a smaller side, so this will be extended to a less larger extent.
Oh,
This will
okay.
be farther off a bit because this is 8.
Yeah.
So
Got it,
that is
got it.
why the AC would be a bit longer.
Yes. Got it.
Okay.
Thank you.
So that is the standard method of deriving the diagonals, or in fact, even if the sides are given and you need to find the area when all sides are different, if you can uh, use this method to basically draw the perpendiculars, then use two equations to get, like, first the remainder, the sum of these should be equal to 21, and then you can find out the equate the height equation from Pythagoras from both of these triangles to basically equate them to each other. You can get the second equation, solve those three equations to get the sort of the over outstanding portions here, and then the diagonal will be from this triangle itself. So that is basically it in terms of polygons. We had already covered these questions, the hexagon and the octagon questions. So hexagon, again, just to sort of revise, it was construction of an equilateral triangle to figure out the remaining sides, and once we did that, then we subtracted three equilateral triangles from the bigger equilateral triangles to get the area. Octagon is again rectangle plus right angle isosceles triangles. So this and this, so this entire side would be this was given. So this will be upon root 2 upon root 2, and then you can figure out the area of the trapezium, or you can even like do rectangle plus two isosceles triangles. This is just based on a general principles of this. Before this, we had done like quite a few questions on triangles. So triangles and polygons stand complete. Uh, like there's no concept that is remaining there. And in triangles, we've done like 20 plus questions. So like, yeah, between yesterday and today, there would be 20 plus questions typically that we have covered. And yeah, so in case like you have any doubts, and would like strongly recommend you to go through all of these questions for both these topics, like before we regroup for the next time, and then we can start with circles there. Since it's a new topic, won't like to start it now because otherwise again it gets a case of like over information at times. But yeah, so next session we'll focus on circles, both theory and questions. So polygons, also polygons, we had only like 5 or 6 questions because like they typically encapsulate whatever we had to study on polygons. So like 5 to 6 questions cover the concept. Trapezium specifically, we had like 3 or 4 varieties, so should be okay. These so nothing will come outside of these 3 or 4 varieties for trapezium. Any questions or any doubts before we sort of put the curtains on today's show? Okay, guys, we'll take that as a no. The recording comes out in a while, so we'll upload that on the portal. And yeah.